Okay, so I watched another video on the dynamic programming, and I implemented a problem. And I did it a couple of different ways because I kind of changed it from before. If you wait, so first of all, he outlines this method, right? And the first step of the method is to find the objective function f of I. In this problem, it's the number of steps up the ith stair. And this problem is the ways you can traverse up n stairs by taking one or two steps each. So define the objective function, figure out the base case, which is 1 and 1 for both 0 steps and 1 step, because there's only one way to traverse up those number of steps. And then find the recurrence relation. I think this is the hardest part, but for this one it's pretty easy. And it kind of clicked. This is like the part where it clicked, because it was like the way to get up ith step or nth step is to calculate the way to get up n minus 1 steps plus the way to get up n minus 2 steps, because that's the only way you can get to the nth step from n minus 1 or n minus 2. And the fourth step is figuring out the order of n, right? And so because the order of n, or because n goes from relies on smaller values, then it would go from bottom up, right? And then the fifth is to find the location of the answer, or location of whatever you're calculating. And I don't really know. Like, this is pretty simple for this problem. It's just n, or f of n, or whatever. But for the next problems, maybe for more variables, it's going to be more complicated. So yeah, this is the problem. It's pretty simple. And actually, I was talking about yesterday how you could maybe trade memory space for time complexity, and that was kind of what dynamic programming was. It turns out that you don't even have to pick with this one, because you can implement it with less time complexity and also the same space complexity, because originally you would implement an array called nums of size n plus 1, and then fill the array with the different cases of how much you could travel up these stairs. But in this method, right, he outlined another method to only define 3 variables, and then kind of define c as a plus b, which is kind of like this objective function. And then instead of just increasing the index, which would usually be I, because this would be nums I equals nums I minus 1 plus nums I minus 2, you just shift the variables right. So a equals b, if you imagine like a is the 0th index, b is the first index, c is the second. You just shift a to the first, b to the second, and then do your problem all over again. And then c out c. So it should work. Let me go ahead and run it off screen, because I think my name is on the thing. So here, if I output 5, it should be 8, and it works. So that was this problem. I'm looking forward to kind of the next videos, because I feel like I actually finally understand it. The method is, pretty useful for me, because I feel like in math or science classes, this is what I do for problems. I just write down methods for certain types of problems and write them down in steps. And so if I have this, I feel like I have a little bit more control over the problems.